So, good morning, everyone, again. Today, we are going to be introduced to SQL. So, this week in general, we're going to focus on writing programs that save their output to a relational database management system. And we'll find out what that exactly means later. But you might have heard those words, relational database or SQL database. SQL database is usually based on the language SQL. So it stands for Structured Query Language, which is usually what these relational databases use to communicate, or like you can use to communicate with them and grab the data or save the data. But in general, when we think about technology and technological solutions, most of it is dealing with data. You're either writing data, you're collecting data from people and you need to save it somewhere. You are parsing through data and you want to show things based on this data. Some people buy and sell data. It's a very big thing. So a huge problem is how to store it and how to retrieve it as efficiently as possible. So before we jump into the relational databases, we can kind of think about how should we do this? What is the best way to save data? So an option is always to just save your data in a JSON file or a text file and kind of read it through a program that way. And let's kind of see an example of that real quick. Just get my screens out here. Sorry, a moment. Okay. Sorry, I'm just sharing. Okay. So let's say we're a school and we want to save our data for each student. So we want to save their name, their birth date, their address, and what classes they're taking. So one of our options could be that we have a different file for each student. So each file is, the name of the file is the student's ID. So that's how you can look it up. And then the information is in there. And then here's another student that has their own information. Also, you can do, you can have it where it's a key value pair. So you can have your, whatever ID it is here, and then you have another one afterwards, which, so you can have them all in the same file. But let's just look at it like this right now. So each file is a student. So I have a program that takes in a student ID. So this is an example of how you can use this data and persist it. So you input a student ID and then it looks for that file and then it prints out your student's information. So let's see. It helps if I was in the terminal. Okay. So 3, 2, 1. I'm not sure why this got added. Okay. One moment. changed the name of the thing before. Okay. Okay, here we go. So I was able to enter the student ID and I get the information. So that's one possible way you can have all your data structured in files. But let's say I don't want to retrieve the student's information through entering an ID. What if I want to put their last name and I want to look for that? Or I want to, let's actually explore the last name one. What would I have to do to retrieve this if this is the case? Does anyone want to volunteer to chime in?
Do you mind letting us see the other file? There's a lot of code that we haven't looked at yet. Oh, the other one.
Oh, this one? So this one just pulls the file with the student's name. So this is the data that you're working with. All you have is you're able to retrieve through the ID number and you get this JSON object, which has all the student's information. Yeah, so you won't really get a lot of information from this. I'll make it smaller to see the entirety of it, but that's pretty much it. It's just reading and printing out. Sorry, I don't know why it's going so fast. But yeah, Maya?
Just guessing, since you asked for someone to guess what the next step is. Is there a way to loop through like all of those individual files and say if the last name in that file is what you're looking for, then return that student?
Yeah, definitely. That's one way of doing it. You can take in all the folders, all the files in the data folder, and then you can just loop through one by one and check. Which if you have a database full of like, I don't know, 1 million students, that's a lot of looping through just to find one person. Same goes if you're looking for, let's say, all the students that are enrolled in Art 107. It's the same thing. You kind of have to go through all the documents to find that specific data point and then look at it that way. So we kind of notice here that this way of doing it is a little restricting. So it's not too flexible with how you can access the data. You can access it if your only way of accessing students is to do it by ID. This is perfect because it's very quick. You can do it, but anything else, it's a little more difficult. So has anyone heard of Nosql Database? So Nosql databases are pretty much like this. So they save information in documents and you can just pull it by document ID. And those databases are not, so relational databases are different. That's what we're going to work with. These databases don't know how to interpret SQL, and you can't, it doesn't really follow a structure. You don't have structure, it's just documents. So this is very helpful with like if you have a large amount of data that you can't fit onto one database server, this is perfect. You just have a bunch of documents with all your data in JSON form or whatever form it is. Another use for it is when you're using, when you have data that doesn't really fit into a normal schema. So you can't really, take it out into specific components that you can kind of fit it into. So those things are like chat logs or videos and images. So stuff like that is usually better to do in a document-based form. But we should probably learn about a better way to do this, since that's what we want to do. We want to access a lot of data in a more structured way. So relational databases are, or the relational database management system, so Rdbms, is a model for managing data that was created in the 70s by this guy called Edgar Frank. Edgar Frank Codd, but for some reason his nickname was Ted, which I don't understand. But he used to work at IBM, and he wrote this paper that I will post later to the notes, but he wrote a paper about this and kind of introducing the idea of a relational database model. And a few things that he noted in his paper that were pretty interesting are that the user shouldn't have to know exactly how the data is stored and organized. So if you want to use your data, you should have like a consistent data or a consistent interface that you can always ask your database questions, and it will always give you the data that you need. Also, that if you change the data on the back end, it shouldn't really affect the user that is trying to access this data. So they should still have an easy, consistent way of doing it. And yeah, so these, this way of like document-wise, ones are kind of restricting, and they're not really adequate to what everyday technologists might need. So let's look at converting this to a relational database model. So pretty much when you want to have anything in a relational database, that just means that your data is in the form of tables. So you have tables of different types of data, and each table has columns that are the data types, or the data entities. I'll give you an example. I think it's much easier to see through visual. Can't find my bottom thing. Okay. So here I took out one of the data structures that we had earlier. So this is the student and all their information, right? So let's try to think about what kind of information we're keeping here, right? So here we have, first of all, student information, right? We also have, so the first name, last name, birth date, those all pertain to the student. Then we have an address. So the address will pretty much look the same across all users. So that could be its own type, because it's a type of thing. It's an entity that you can save. And then you also have classes. So classes have their own structure. Maybe you want to put some more information about the class. You want to add what grade the person got in a class or something like that. So let's start by converting this to a relational database model. Okay, so let's say we're creating a student table to house this information. Our first field is always going to be an ID. So with relational databases, you always need to have a unique ID for each row of each entry, pretty much. So the rows are the entries of, like, let's say, different students, and the columns kind of define what your criteria are. So we have an ID. It's always going to be unique. It has to be unique. And then let's say our first name, last name, birth date, and address. So you notice here that the address contains a lot of different ones. So you can't just, you can either compile them all into one string, which is probably harder to read and harder to go through later on. Or you can just create another table, which is great. So let's do that. Okay, so can someone tell me for address, what would be our first field?
An ID.
Okay, what's the second? Based
Probably
on
just
here.
the like line 1.
Yeah. So it's the same thing, line 1, city, state, and zip. Okay. So now classes. For a class, we could have ID again, the name of the class, and we could also add on grade. Why not? So the grade that a person gets in a class. Actually, it doesn't matter. Okay. So let's say we have an address here, right? ID is 1. This information is in here, right? I think it's just easier. Okay.
So do you mind if I ask?
Yeah, please.
Grade would be specific to the student, not like to the
Yes.
student's grade in that class. So is that a foreign key? Is that what you're?
It's not a foreign key, but yeah, I think. Let me check something real quick. Okay. I guess I shouldn't have showed the entire thing, but it's, yeah, I was mistaken. It wasn't the grade, it was credits. So how much is this class worth? And that is a good question to point out, because if you had grade, then if you only have a class, so like CS 101, that class should be able to be applied to any student. It's not only specific to one student. Okay, so here I'll just write, this is easier. Chicago, Illinois. Okay. So we have this, and we have our first student, Megan, Remy, birthday, whatever it is. So here, what we would do is we would actually make this an address ID. So that way we can reference the address that we already have in the address table. So if you were persisting all of this information, you would want to persist the address aside and then have the address ID, and then you can add the address ID into your student. So this one would be 1. Let's move this a little. Okay. So for classes, same thing with the ID. So yeah, we'll talk about this actually later. So CS 101, and then credits, let's say 3 credit course. Okay. So the question is, how do we kind of represent that a student is taking a class? We could add another column here to just say class, but then you might have to add infinite classes because you don't know how many classes this person is going to take. So how do you guys think we could manage this? Anyone have any?
Can you not put multiple IDs, and like you couldn't have like ID 1, 2, 3 in a class column?
So you could, but you would want to, so you're saying, okay, let's say here. So here we add class, and then you're saying we add like 1, 2, 3.
Yeah.
Okay, So with this, you would have to, it would make searching harder because you would have to have special code to kind of go through this string and then look for the IDs of those classes. So a way to go around that, I'm just gonna. So a way to go around that is to make another table that is specific to enrollments. So let's see what this table could look like. So again, we have an ID, but what do you guys think we would have in this enrollment? So what things are we trying to pair up? What entities?
Student ID and class ID.
Yep. Student ID, class ID. And here's where we can put the grade if we wanted. So each enrollment is a unique relationship between a student and the class that they're taking. And you can also, and the grade that they got in that class. Any questions so far? No?
I have a question.
Uh-huh.
Can you hear me?
Yeah.
What is making you decide to choose these relationships? Like, how did you decide to make like, is this just kind of arbitrary, or is there like a procedure for deciding, okay, it makes sense to make an enrollments relationship at this point?
It pretty much just like it makes sense. You kind of just want to abstract your data into as small pieces as you can. So you want to have full entities that kind of like objects. So you have a student object, you have an address object, and each student object has a reference to the address object. And since the relationship of students and classes are like one student can take many classes, it's much easier to, what is it called? To do it in enrollments, because to have it into a different table, because that way you can have each line be its own relationship between the two. So this is pretty much representing the relationship between students and classes. And you have to do it because many students can take many classes. Did that kind of answer your question? Or?
Yeah, so in general, should you just go for as many abstractions as you can? Is that kind of the idea?
In a way, I'm weary about saying yes because I don't know how abstract it would get, but I would say, yeah, try to make them into like good chunks of data, like each with its own type kind of thing, you know? So this is a student type, this is a class type. Trying to keep the information relating to the subject in that table.
So is the student not going to have the link to the enrollment?
No, so the enrollments will be the link between the students and the class. So it will kind of be like this. Oh, stuff got deleted, but whatever is in here. So you pretty much take the ID from the student, you put it in here, take the ID from the class, and that's where it goes.
So
in here.
So you won't be able to search a student for their enrollments? Is that how that works? Or
Yes, you would have to reference the enrollments table to find which student has the enrollments. So we're going to talk about this in a little bit, but SQL has these things called joins, where in one query, you're able to get data that spans multiple tables. So you would be able to get this through one query. and I'll show an example later.
So also along the same lines, if you wanted to make like a school relationship, you'd have a school and then you'd have a column for students, and then
Mhm.
each row would be each individual student ID.
Mhm. So are you saying that it would be like different schools?
No,
Like just one school?
well, I mean, I
So-
guess you could have one for the schools also if you want a higher hierarchy, but I was saying like, if Megan is a student at Homewood Elementary and you
Mhm.
wanted to be able to find all the students at Homewood Elementary,
Yeah.
then you'd have one table for Homewood, which would have one of the columns would be student, and then each row would be the student ID.
So in that case, if you're having, you would have a table full of schools, and so you would have, let's say, okay. So this is for all schools. And then you would have your ID, your school name, and you could have your student ID. Actually, this is not the best way to do it. So why do you think, why is this not the best way?
You'd be in the same position that you were talking about with the enrollment block.
Yep. So we would have to say, if it's schools, then all school information would be here. So the school name, maybe school address, something like that. So we would have to have a separate table to be like school enrollment or something like that. So then we would map a school to a student, which is kind of what we were doing in this table here, the enrollments.
So why couldn't we add a column to students for which school they're at and then join the students with the schools?
So we can, it just depends on, yeah, so in that case, we would have, what is it called? I forgot what I was gonna say. So an extra column here, school ID, right? And then it would just point to whatever school it is, right? Is that what you're saying? Yeah, that's a way of doing it, yeah. So these schemas can be done in different ways, and you're kind of just trying to do the best that you can, pretty much, given the data, given the structure. Alicia, I think your hand was up.
Yeah, I was just gonna ask, is it a good assumption that basically, like you start with one, what are these table things called? Relationship, what is it?
Tables? It's a table.
It's just a table, okay.
Yeah.
That like for every table's columns, you'd have another table. Like, is that safe to assume that, or you would decide up front, okay, I want the user to be able to search by this, 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 and this, and so I'm going to create a table for each one of those things.
No, so you don't need a separate table for each one. You only need a separate table for things that you might need more information about. So like, let's say the address. Instead of keeping like address line 1, city, state, zip code, all in the student, you can take it out into its own table. It makes it easier. That also, if someone has the same address, you can just use the address twice. But it makes the table more manageable when you have less columns. But when you need another table like enrollments is when you have relationships that you can't adequately put into one column or a few columns. So it's, if we have students, it's not really the best practice to put their class, well, it's not good at all to put, let's say, the string of all the IDs, because you can't really look it up with SQL that way. You would have to do a lot of extra steps. So you want to make your life as easy as simple.
So
as
basically,
possible.
anytime you find yourself wanting to add an additional item to that column, then that would like tell you, hey, I need to make a new table for this.
It depends on the item. So if we're adding, let's say, and I don't know, what's something we can add about the student? Birthplace. I don't know why they would need that, but if we were adding birthplace, we would just add another column called birthplace, and that's it. If we wanted to add the student's university ID, let's say, then we would add just another column for university ID, because that's unique to the student. Yeah, does that make sense a little? Or?
And just to add on to that, Zainab, what you were saying before about like one-to-many relationships, that like a student can have multiple classes, and thus like multiple enrollments and multiple grades is a big part of when we decide to make different tables too, because putting things in different tables is a good way to capture and represent those like one-to-many relationships.
Yeah.
Yeah. I just want to add real quick. Kind of a rule of thumb is that one column in your table should only have one piece of data. If you feel compelled to put a list of data into one column, that's a good clue that that should probably just be a separate table entirely. And then you have to think about the relationships between those tables. But also today in general, we're aiming to just give you kind of like an overview of SQL. So all these questions that you're asking they're great. They're really important, but this is actually the main subject of Wednesday's lecture. So if this is still feeling kind of fuzzy to you, just like how should you organize your data into multiple separate tables, like don't worry about that quite yet. After you learn about the mechanics of SQL and what you can actually do with it, it'll, I think, be easier to answer these questions on Wednesday. And we'll be able to think about how is a useful way to organize our tables given what we know we can do with them. So I'm asking you just suspend disbelief a little bit today. This will become much more clear on Wednesday.
Anyone else have any questions? I think Evan, you had your hand up, or?
Yeah, I was gonna ask a question, but Raphael answered it in his little soliloquy.
Okay, awesome. Anyone else? Oh, okay. So, okay, one more thing about tables and the columns. So when you want to create a table, you have to decide what type these columns are. What is it called? There's numbers, there's characters, there's like different types, data types. I actually have a little table over here. So you have these are the most common data types that you'll find. So you have an integer, which is just numbers, decimal, fractional numbers. The cool thing about decimal is, I guess you can just look this up later, but when you choose decimal, you can choose how many numbers before the decimal point and how many numbers after. So if I want to only have like up to 3 numbers and up to 2 numbers on the right, this won't let you enter a value that is not within these constraints. So an important part of relational databases is that it kind of does data validation for you. When you're setting up your table, you decide what your columns are supposed to house. So let's say if you have a birth date column, you want it to be a date. That would probably make more sense. If you have, let's say, credits, you want it to be a number. You don't want to have any number letters in there. So that's just something that you can incorporate into your table. That makes your life easier when you're making sure all your data is supposed to be what it is. So let's trying to decide if we should look at some SQL first, or should we go over some of the Postgres commands and stuff. Let's start with Postgres. Did you guys get a chance to install it? Hopefully you did. So when you install Postgres, it installs a couple different things. So let's start with a basic command line. Okay, so Postgres is one of those database management system, a relational database management system. And it gives you a few command line prompts, and then it gives you pSQL, which is its own, I think, interpreter. Is that the right word for it?
I call it a database client.
That's a better, yeah, it's a better way to put it. So pretty much when you go into pSQL into a certain database, you are just writing commands specifically to that database. So before we start anything, you have to start your server. So it's just Postgres. I think I don't have to do anything else. Yeah, okay. Did I start it up already? So they also give you a tool. It's called Start Postgres. So you don't have to do it through the command line. Okay, so we'll tell if it works when we start pSQL. I hate how slow this is. Okay. So many opened. What is this? Okay. All right. So before we start pSQL, actually, we need to create a database. So generally, you have, so Postgres manages a server for you. And in that server, you can have different databases. And you would want generally each database to be specific to the problem that you're solving. So let's say if we're doing the example from before with the student database, like the student information, we would have a school database. So that school database would have all the information about students, classes, all that stuff. So the command, yeah, I'll also have these posted later. So I wrote down a few commands that help. So to create a database, we do create DB and then whatever database we want. So let's do test right now. And then we do pSQL test. So we want to go into that database. And we're in. So you see here, this usually tells you what name of the database, what's the name of the database that you're in. So I do want to show you guys the other tool that they have, which kind of is sometimes nice to see things graphically, or if you don't really like looking at the command line, which I would say like command line is very good, but it's called PG admin. So this is also installed with it. Hopefully this is not just a Windows thing and that everyone would be able to benefit from this, but so when you log in, you have your servers. You might just be in Postgres SQL 14. That's the default one. I created one that I was just kind of playing around, and I created it going towards the local host, so just my computer, and it kind of rerouted everything from this one to this one, and I didn't want to mess with it any longer because I didn't want anything to break, so I just left it as it is. But yeah, so these two databases were in there before, and now if I refresh, I should be able to find, yep, the test database that I created. So this is one way to check that you did the thing correctly, or you can just, check it through the command line like we did. Okay, so don't want to switch context too much, not to confuse, but okay. So if we want to see what the databases, which databases we have on our server, so if we want to switch to a different database, this is one of the commands. Right now, I don't really have any ones that are helpful. So let's put some data in there. Let's kind of play around with the database. Let's close all of these out. Okay. So one of the ways that I've interacted with SQL in the workplace was I had to write Python scripts to pull in CSVs, grab the data from those CSVs, and push them to a SQL database, or grab the data and then do some manipulation on the data and then push it to the database. So you might come across this. So having to write a Python script to upload data to a database, or just pull data from a database. So this library is called, I think, PsychoPG. I don't know the pronunciation of it, but it's a very useful, what is it called, library that allows you to connect to a Postgres, what is it called, database. So the most important things that you need to know is there's just a connect string. So you just connect, give it the database name that you want, your username, password, host, and then port. And then it kind of gives you this thing called a cursor. So you don't really need to care about this stuff unless you're actually manipulating stuff with Python. I just wanted to kind of show you one of the applications of it. So I wanted to create a table. So I have my database test that I created, right? So this is what SQL looks like. So you have here two statements. Your first statement is saying drop table if exists, and then you give the name of the table. So generally when you want to create a table, you want to make sure that another one with the same name doesn't exist already. So if you want to create a table, this is the same if you want to like edit it or something like that, like you forgot to put a certain data point or something like that, then you want to drop it and stuff. But regardless, when you're creating a table, you would want to drop first if it exists, and then create table. So the syntax, yeah, Jacob? Or Jake?
I'm just curious, like I see that we're in a Python file.
Mhm.
Is that like the drop table, is that a command that like gets put into the command line, or is that
Yeah,
I
so
guess like
actually,
what
let me just
language
do
is
this.
that?
So I'm just gonna copy this. This was an example. I was like, oh, this is gonna make it easier, but I think if I just do this from the command line, it's so much easier. Okay, so we're in our test database, right? So we say we want to add a table called test. So we can say drop table if exists. If you don't add the if exists and it doesn't exist, then it will cause an error. So that's why you put it there. So drop table if exists. Test table. Oh, you need a semicolon here, I forgot. Okay, so the drop table went through. So now we want to create one, create table test. And then you enter the fields that you want. So, so this is kind of nice in the command line. So if you don't put a semicolon, you can keep hitting enter and it's still within the context of that one query. So I just hit enter after I open my parentheses because I want to add more stuff. So first we want our ID, the syntax, or not the syntax. So we want to add the data types for these things. So Postgres gives us this really nice thing. It's called serialized, I think, serial. Oops. Actually, you know what? Let's do that. Okay. I'm going to copy what I had before. Okay. So serial, that's what it was. Okay. So when you open your parentheses, that's where you put all of your columns. So we want an ID, and these are the types. So serial means that your database, when you're entering records, so if you enter anything into test, it will automatically create an ID, and it will always, it's going to start from 0, I believe, and then keep going, incrementing up. And primary key means that this is the primary key for your ID. This is how you can identify each record. So it will automatically be not null. So you can't not have an ID. And also has to be unique. So each record will be identifiable by this ID. So that was something I didn't mention earlier. But so you can have a table that doesn't have ID per se, but it would have a different field that would represent their primary key. So if we have a student and in the records, they have their university ID, and that's a unique ID. You don't have to have like a specific column called ID. You can just have the university ID be the primary key, and that's it. And then if we want to add just a number into this table, so that can be type integer, and then data could be type text. So text is long strings. Let's actually do so varchar is, I don't know if people say it like that, I say it like that. It's a variable length string. So you can, it goes up to 255 characters. You generally use it for like a lot of things like names and yeah, I guess names and stuff like that. So it can be characters as well. So let's just do 100 as the max. Okay, so now if we execute, we have created a table. I saw someone put their hand up earlier. Anyone?
It's me, you answered it.
I mentioned it, you said? Okay.
Yep.
Okay.
Where's your table?
So the table, so I put this, this script in and it said create table. So we're gonna check if the table is actually there. So to list the tables that we have in a database, we're gonna do /dt. And there we go. Now we have a table called test. And this is the owner. I think if you do dt plus, you get a little more information on, yeah, just the size. So the size is 0 because we don't have any records in it. And also you can see it. Yeah, Terrence.
Yes, so I saw you had create table and then you did create table again. Is that how it works?
No, I only did one create table successfully. The first one I was starting to type it out, but I forgot the serial word. So I just kind of inputted a wrong one.
Not that one. I meant okay, I guess Elisa just answered it. No, I just saw create table twice, you know.
Oh, that was the response.
Okay.
Yeah. So I entered this until the semicolon and the server responded with create table. So that's what it did. It did a command that created a table.
All right, cool. Got it.
But yeah, so also it's also in here. So one thing about this interface that I don't like, because I used to use like Microsoft SQL Server Management Studio, something like that. It's a little easier to see your tables and stuff, but yeah, so your tables, we have one, which is test. Okay, it doesn't matter, but it's in there, you can see it here. Okay, so let's add some data in here. Actually, any questions before? Is this kind of clear? I know it's a little new, but yeah. Yeah, Michael.
You said that the PG admin program was just like a visual like representation of the command line.
Pretty much, yeah. It has, yeah, it has pretty much all the functionality. I don't know if it has more. There's definitely like a lot in here. There's way too much, but it has good functionality. You can also like add your tables from here and stuff like that, but I wouldn't recommend it. It's, I don't know, you do you, but it's better to know how to write the scripts, because it's a lot of cases you're not going to be able to use like an interface, and you have to physically write the scripts to create your tables, to insert your data and all that stuff. But yeah, I think it's a little helpful in the beginning. But yeah, don't get too reliant on it. Okay, so now we have our data or our table. Let's insert something into it. So let's do insert. What do we want to insert? Forgot the structure of it. Oh, it's just number and data. Okay. Oh, also, if you forget what your columns are in a table, this describe a table, and it just means that it'll give you what your table is. So just, I don't know why I'm doing describe. So -d and then test. Oh, here, I don't know why I was looking up there. But yeah, so you have these 3 columns pretty much. So we want to insert into test. When you open parentheses, you put which columns you're going to put data for. So I want to put data for the number column and the data column. And then you specify which values. For number, let's say that, and then value something, I don't know. Let's see. So it seems like the insert went through. When you want to see what's inside your table, you do a select. So select. You can do select star for all, or you can do select top one from test. Does top one not work? Oh, I have to, never mind, I remember. I'll go over that later. So I'll just do select star from test right now. Which didn't. John? Yeah. I can't hear you.
I think he was asking if you can make it bigger, the window.
Oh, yes, yes. There we go. Is that better?
So aside from using that extra GUI, is there a way through the terminal to see the columns and everything of your table? Because I was trying to like remember, wait, what were the columns of your table? Where's that data going into?
Yep. It's this.
Oh, you
command.
did that.
Yeah, yeah. So
Okay, sorry.
/d for describe and then your table name.
Got it. Sorry.
Yeah. No, that's okay. Yeah. So it'll give you the column names and it'll also give you the type. So I realized that I didn't put a semicolon earlier and I did it too late. So select star from test. Semicolon. There we go. So now we have the data that we just entered. Any questions so far?
Yeah, so I noticed you're hitting enter before you put the semicolon. Is that like how we have to do it, or can we just put the semicolon after on the same line?
No, you should put the semicolon on the same line. I was going too fast and I just hit enter and I didn't, yeah, that's why I had to put it afterwards. Yeah, Michael?
So I'm just curious, is SQL case sensitive? Because I feel like every time I've seen SQL written out, usually like commands are like caps, but then when you did like your select thing, it wasn't. Is it best practice to do like caps for commands and like lowercase for like values, or how does it work?
I've seen it like that, but yeah, it's not case sensitive at all. You, if you want, I think it's only case sensitive within like strings. So not I think it is. So if you're comparing something or if you're writing a string, that's case sensitive, but in the actual statements themselves, it's not.
Okay, thank you.
Jake?
Yes, I'm sorry, I'm just trying to understand the terminology here. Are we using Postgres or SQL, or are they the same things?
So SQL is the language that you can speak to the database with. SQL stands for, what's the first one? No, not standard.
I think it's standard.
Structured query language.
Yeah, structured query language. So it just allows you to speak to the database. Postgres is the database management system. So it's the entire thing built around like the database structures. So it allows you to create databases. It allows you to create tables within these databases and manage all of the relationships. And yeah, so SQL, you just use it to communicate with the databases, and Postgres is managing all of that.
Okay, awesome, thank you.
For clarity, there are many different databases that use the SQL language. So in your first job, it's very likely that you'll be using Postgres as your database because it's very popular. But if you're using any other database, as long as it's a SQL-based database, 99% of what we're teaching you here is still going to apply. So lots of different RDBMS systems use, well, actually all RDBMS systems use SQL, but lots of databases generally use SQL as the language you use to communicate with them. So this is more general than just Postgres.
Zainab, a couple folks in the chat were just wanted to check in about a break. So I just wanted to let you know.
Yeah, I was actually just gonna say, like, whoever has any more questions, and then we can take a little break. Any questions about this? No? All right. When should we bring them back? 11:30? Or
How about 11:25?
25? Sounds good. Yeah, I'll see you guys at 11:25. Okay. Any questions before we begin or continue? No? Okay. I assume you're all experts in SQL now. Oh, okay.
Yeah, so I was looking at your code when you're inserting it into the in the command line. So do we not have to specify the ID? Will it automatically give that something as the primary key?
Yeah, so when we created the table, we set the ID to be serial. So that pretty much means that the database is automatically tracking the ID number. So it starts from the beginning, it starts from, where is it? It starts from 1. I was incorrect before. So it starts from 1 and just keeps incrementing. So yeah, if you insert, let's say we wanted to insert the ID also and specify which ID. So I wanted to insert this first record, and I specify ID 1. I have to manually go in the in some config thing. There's a function where you can increment that. So there's something in the database that is keeping track of those IDs. I can show you actually. The /d or yeah, so /d shows you 2 things versus just the table that I created. So it shows you the table, but also shows you this. So the ID sequence is being tracked. So it starts at 1, and then the more records you insert, the more it increments. But if you specify the ID before, then you're going to need to increment this manually, which we'll see an example of actually.
Okay, great, thank you.
Mm-hmm. So let's back to this a little bit, this mess. Let's try to write a query to, or a statement, sorry, to create a students table. Caleb, do you still have a question, or is that, okay, cool, awesome. Okay, so create table, what do we want to call it?
Students.
Yep, students. Okay, so ID is going to be the first. What would we want to put here? So if we want it to automatically, I didn't know that does that. If we want it to automatically keep track of the IDs, we can do serial. So that's one of the data types. And also what? Do you remember? Yep, primary key, Skylar. I also have the chats open now. I'm sorry, I wasn't looking at them before. So serial and then primary key. I just wanted to get rid of this. Comma. First name, what data type would that be? Let me bring this up here. So what data type should we do our first name?
Varchar.
Okay. Varchar. So with this, we can set the max to be something like specific, but if we aren't sure how big the field could be, we can do it to the max, which is 255. Same for last name. So birth date, what would we want this one to be?
Date.
And address ID would be probably an integer. Okay, so everything looks good here. So one thing that you can specify while creating, which you should specify while creating a table, is which fields are not allowed to be null. So for sure, for a student, you would want their first and last names and date of birth. So you would just say not null. Again, not case sensitive, but just kind of to differentiate. Not null. This one, not null. And I guess the address, huh?
I'm sorry, does that mean they're null by default?
No, it means when you're inserting a record, it cannot be null. So you have to, when we're doing our insert statement, you have to put these fields pretty much.
Right, but if you don't put not null, that means that it can take a null?
Yes,
By
and
default?
it will be,
Okay.
it will be null by default. Correct. Yeah, so this pretty much looks good. If we wanted our address ID to not be null, we can also put it, but then we would have to for sure give it an ID. So let's try putting this into our terminal. Okay. Yeah, Dalton.
I'm assuming the ID is not null by default. That's why you don't have to put that in there.
Yes, so if you put primary key, that means it's not null by default. Yeah.
Cool.
Yeah, thank you. I didn't mention that. Okay. So everything looks good. Create table. Okay, so now we can test. Actually, I am going to change my database. I would like to create a database that is specific to this schema. So we're going to create a students database. So the command is create DB, and we'll call it school. So all Postgres commands like the create database and pSQL and stuff, those won't run unless you have your Postgres server running. So when we did Postgres in the beginning, and we hit enter, that means that you're starting up your server. it'll give you an error anyways, so you'll know. So now I can go back to my other terminal and change my database, which command for was -C. Okay, so \C and school. So now we're in our school database. Does clear work? No, it doesn't. Okay, just scroll. Okay, I'm gonna create this table in here now. Awesome. So let's check. We have our table. We want to check on all the fields. We'll do students. There we go. So now we'll make sure that we have all of this stuff. So we can insert a record. So insert into students. I'll do first. Birth date, and that's it. I don't want to put an address right now. And then we specify the values. Tom, Jerry. And so the date field is pretty cool because you can put it in different formats. So you can put the year first. So let's say 1996. Something. Actually, I think the month has to go first. I don't know. Do you have either Raphael or Adam? Do you know if the month is in the middle or the day is in the middle?
It can vary, and I don't know what it is in this case, but I can Google it. Find out.
I would guess your month day.
Mm-hmm.
Yeah, it's month in the middle. That's a good question.
Let's say 22 to make sure. This syntax also works if you did like, let's say 30 of, I don't know, March 2022 or something like that. So if you put it in this format or put slashes here, it should all work and take a date. Okay, let's see. So this is incorrect, probably because I have to have single quotes around my statement. Yeah, there we go. Okay, so now we've inserted, and then we can select start from students. Awesome. So the select statement is very, very powerful. This is where you can grab the data that you need. So you can actually, you don't have to get all of the columns. You can specify which columns you want. So select, we only want first name. I can spell it correctly. First name from, what's it called? Students. Here, it only shows you the first name. So if we had more students, it would show all the first names of the students. If we wanted to specify, so let's insert another record. That's okay. Actually, I'm just gonna go up. So I'm pressing the up key to go through my old commands, like regular terminals. So let's just change this stuff here. So we've inserted a new record. We can do select students or first name from students. And now we have both students. Let's say we only want to specify one of them. So we want only the person with the first name Tina. So we do select. So star is for all columns. That's what it references. So select star. Students. Where, so the where clause is where you put your conditions. Where first name equals T. There we go. So we got the record with that first name. We want to do last name. We get both of them because they have the same last name. Let's say we want to do only the first record. So we say top one star. So the star references the columns, the top one references how many rows. So you can do top whatever number of rows you want. How, actually, it might be like a Microsoft syntax thing.
Yeah, I think top is MS SQL. Is limit one what you're looking for?
Ah, okay. Is it at the end or here?
I believe at the end.
At the end, okay. Or do I need parentheses? We'll find out. Oh, this works. Okay, so now that same one only gave us the first one. Any questions so far? One second, let me just check the chat. Select star. Yeah, so select star is for all the columns, so all the data points in that table. And then the limit is for how many rows you want to actually view or return. Okay. So I created some scripts. So this is part of your homework. So I'm not going to actually show you the script itself for the creation of the schema, but I created the rest of the tables that we designed earlier. So the student, class, address, enrollment, all that stuff. So the way to, so you can create your tables and all of that and do your inserts one by one through the command line, but you could also write a whole script, and that script is just, let me show you an example of it. So okay, so it's just the same, literally the same thing that we wrote earlier. So create table students, and then you specify all the stuff that's in there. And then you can have another one after that, which says create table, what was it, addresses. And give the information. So you can put multiple statements in succession and just run the entire file all at once, which is very, very helpful. So let's cd into my SQL scripts. So right now I'm in the folder where I have the scripts that I want to run against the database. So the way you do this is with the command psql. So we're going to use psql, the database that we want to post these changes to. So I want to choose the school database, and then you use this to like pipe in information pretty much. So the lesser than sign, and then you put the name of your script that you want to run. So mine is called create schema, create tab. It just auto completes, which I love. Yeah, so now it created my tables. So I can go back to this here, and I can see what tables I have now. See, now I have 4 tables.
What was the file ending to create the script?
SQL, so .SQL or .SQL. Here it is, these files over here. Yeah. And then you just do the command like this. Yeah, Dalton?
So I kind of have 2 questions. So one is, so is it Python that's running the SQL script, or is it pSQL?
No, it's pSQL. So this has nothing to do with Python. Yeah, those were closed. This one. This is, I'm just using the terminal that's over here.
Cool.
Because I already had it to this, yeah.
For would this only work if you have a pSQL server running? Like you couldn't run that without the server up, right?
Exactly. So you have to, before you can do anything with like pSQL and all that stuff, you have to start running your Postgres server. So you have to do that first Postgres command, yeah.
And I'm assuming it automatically saves. You don't have to worry about it like not saving.
Yep, exactly. So that's why I was able to run this command in this terminal and then go to the other terminal and check, and the changes were there. So it's all, they're all like different entry points to the same system that's underlying.
Cool.
Yeah.
Thank you.
Any other questions? Yeah, Michael?
Just to be sure, so in order to run that script where you created all those tables, you have to have Postgres and everything running in the background?
Yeah, correct.
Okay, thank you.
Actually, let's try it without it. So I had started my server with that one tool, so I'm gonna just stop it this way. To give it access every time. I don't like it. Okay. So let's try it again. Yeah. So you see the database system is shutting down, or well, that's just because it's in the process of shutting down. It will usually tell you that the database system is offline or something like that. Yeah, could not connect to the server.
Okay, thank you.
So let me run it the regular way. So Postgres. There we go. Now the server is running properly. And if you want to,
I just wanted to point out the localhost 127.0.0.1 IP address that we see there, which is the same that we saw with our Django server.
Yeah, right here.
They're on different ports, but again, that's kind of the standard. That's the IP address for one zone machine.
Yeah.
Sorry, Zainab, I didn't mean
No,
to.
no, that's okay. Yeah. No, I always forget the actual number, so I have to look at it. I don't usually look that up. I just put localhost because I'm lazy. But yeah.
I do that too, to be honest. Yeah.
While we're talking about numbers here, I do actually want to point out the port numbers for Postgres versus other things. You know, web traffic is usually on port 80, which is why in development we're running our Django server on port 8000 because it's a large number that kind of reminds us of 80. Postgres always runs, well, not always, but by default, it runs on port 5432. So these are little clues that you can keep in mind that might help you out in the future when you're trying to debug, services running on different ports. If you see something come up on port 5432, you can kind of assume that that's Postgres. Or if you think Postgres should be running and there's nothing on port 5432, then you can kind of infer that there's a problem. So this isn't just like low level details that people just gloss over. I want us to pay some attention to this because I swear this can be useful in your future. All right, that's my soapbox.
Is there like a limited number of ports on that node, or like could you start one on port 1, or is there any significance behind the number themselves besides the meaning?
There is a limited number of ports, but there's about 67,000 of them. So practically speaking, there are more ports on your machine than like you have memory to run simultaneous servers. There is kind of some special meaning to the numbers. So generally low numbered ports, so 2 or 3 digit port numbers, those are actually like for specific services. So like HTTP is port 80, HTTPS is 443, SSH is on 22, FTP happens on port 21. Generally speaking, the large port numbers are not for any specific purpose. So we can just run test servers on them and it's not going to conflict with anything else. And so you might notice when you're trying to run a server like on your local machine, it's really easy to run a server on port 8000. But if you wanted to run something on port 80, you need administrative privileges because those are like special ports, I guess. So you'd have to use sudo to pretend to be an administrator to run a server on like port 80, for example. So there are like sometimes small differences between them. I guess the low number ones are like more official. The high number ones are kind of not reserved and you can do whatever you want with them. Does that help?
Yeah, thank you.
Cool.
Yeah, and just to jump on that, because it is, I think it's cool. Yeah, and the analogy, I know, just to repeat, because it's helpful to reinforce, like the IP address would be like the address of an apartment building and the port number would be the apartment number. And we see this client server architecture again that we saw happening with our web app, with the Django web server and the client being the browser. And we see that again here with the database server. And then we have a client, which is some program interacting and talking to it, whether it's PSQL or some Python code that we write. And similarly, like the database server could be living on a different machine somewhere, and in a real application architecture often does. I just wanted to touch on that because I know a lot of folks had questions around client server architectures and sort of what's a client and what's a server, and just wanted to jump on this to share that because it's such a core like architecture that you see, and I just think it's cool because once you get it, then it's everywhere. So yeah, I'm just going to pause there, and sorry for the digression.
Not at all. Thank you for the inputs. Any other questions before we continue? Okay. So now we've created our 4 tables, correct? So I have a script here that you'll also see tonight. The script pretty much just inserts data into the databases that were just created. So we have, in the beginning, we have some addresses that were inserted. And then we have some students. So here you notice that the IDs are actually specified because we wanted to insert addresses with certain IDs for certain students. And then we have our classes, so the name, the credits, and the enrollments. So this person took history and got a B. So this is what this means. So the first student took the second class and the grade was B. And some of them are currently taking, so it'll be null. So yeah, there's a few of these. So like I mentioned before, if you insert what is it called? If you insert your ID, you would have to manually go back, and kind of increment the sequence. So at the end of this file, this pretty much sets the value of addresses ID sequence. So in the database, when we created the IDs as serial, these were automatically created. So we have these 4 variables that are keeping track of our sequences in different tables. So what this is doing is it's setting the value of this to the max ID from the table, the respective table. So it takes the max ID from addresses and then sets it equal to the sequence. So that way, next insert, it's going to be the next one. So I will do the same command. So I want to load this into my database. This is seed data. Okay, I didn't get any errors, so that's very good. Okay, so now we can check on the table. So we can select star from students. So I need to redo it. Okay, so now we have our new students. We could also select from enrollments to see what that looks like. Okay, so it's just mapping the student to the class. So let's try to play around with some queries, trying to extract data out of this. How would we write a query? Yeah, Dalton, before we start.
Well, I don't understand what that you just did. Can you go back to the other line of code?
So the way I ran this script. This entire script is just inserting data into the tables that were created. So these 4 are 4 new addresses. These are new students, classes, enrollments, and this one, did you miss the?
Yeah, that's the portion I don't like, from
Okay.
lines 61 to 64.
So up here, pretty much in all of these, we specified what the ID of the row that we're inserting. So here we specified that it's 1, 2, 3, 4, and so on. So with all of these, we have to manually make sure that the database knows of these IDs that we inserted. So when we created the table, we chose ID to be serial, which means that the database automatically keeps track of what the next ID to give when you're inserting. But since we manually did this, it's not incrementing anything because we already chose it for the system. So what this is doing is it's taking the max ID from the table. So max ID, whatever the highest number is, and then it's setting it equal to this variable that the database created. So when we created the table with the serial ID, this was automatically created in the background. And this variable pretty much just keeps track of what is the last ID number you used. So in the beginning, all of these are 1 when you create a table, or sorry, all of these are 0. And then, what is it called? You would wait, the sequence. Yeah, no, it does start at 1. So this is like, if I'm inserting, what's the next value that I take? So you take addresses ID sequence, I mean, and then it increments it for the next value. So here, all you're doing is, for enrollments, let's say, our biggest ID is 16, right? It needs to know what to do next, pretty much, if you're inserting without specifying which ID number. So we're just setting this equal to the biggest ID. That way the system will know next time we insert into enrollments, and we don't have to because we don't have to specify the ID number, we can just do an insert and it will automatically know that the next one is going to be 17 because the last one was 16. Does that make sense?
I kind of, but I guess I'm kind of confused with the naming conventions about it. So
Here?
yeah, so
Okay.
there's never an addresses ID before line 61, correct?
Sorry, say it again. There's
Like on
never-
line 61, there,
Uh-huh.
that's the first time you've ever set addresses ID, correct? Or is that?
Yes. So this variable is only accessed by the database in the background. So we don't usually use this when we're inserting. So if I was doing a normal insert into enrollments, I would do the same line, but I wouldn't specify the ID at all. And so when I do this insert, then it should be 17. Does that make sense?
And it would be 17 based on what line? Line 64, I'm assuming?
Yes, line 67 actually, because that's the one doing the enrollments one.
Okay.
So for this one to actually work the way I expect it to, I would have to put it after these because up until that point, they're not reset. So it would try to give me the ID of 2 or 1. Yeah, it would try to give me ID 1, but ID 1 is already taken. So that's going to give me an error.
Cool. Thank you.
Mm-hmm. Any other questions? Alrighty. Okay. Went back too many. Okay, so now we're back in our schema. All of our data is loaded into our tables. So let's say we want to select the students where with a specific last name. So how do we do that? Someone give me, tell me what should I write? So I want to select some data.
I think I can give it a shot.
Mm-hmm.
So you said that you want the student's last name, correct?
Mm-hmm.
I think you would want to do select star from whatever the table is named. So students.
Uh-huh.
I think I need help. That's just
That's okay. So this is where that's where you can start putting your conditionals. So where what column name do we want to specify?
First name. So is that just like, can you name it?
Yep.
First. Oh, okay. Gotcha.
Students with first name equals pick one.
Jed.
Okay. Jed. There we go. So it pulled out the record with the name Jed. How about so this one I might need to help, but let's say we want to list let's list all the courses first. So all the classes. So select.
Zainab, I think John had a question.
Yeah.
Can you hear me?
Yeah, I can hear you now.
Oh, okay, now it's working. All right. So you said that, so in this last example that Jake did, the string is case sensitive. Is there, if you're not sure what where the capitalization is, or if it's capitalized or not, is there like a way that you could just query it where it's not case sensitive?
Yeah, there's I don't remember the exact command because I'm used to using like Microsoft SQL, but there is one that you can say like uppercase or lowercase for
Okay,
this
cool.
term. Yeah, yeah. I think it's literally just like, I mean, not right after the. So where I think upper of first name equals Jed. So you can do something like that, if I'm not mistaken. I guess Adam or Raphael, you can correct me if I'm wrong.
It looks correct,
Yeah.
but this is the kind of thing that I would have to Google if I was gonna do it.
Okay, yeah, so we should just Google it.
Oh, that's okay. I just
Yeah.
want to know if it was possible. I could Google it on my own.
But yeah, it is possible. So let's start from classes. Oh, I didn't do from. Also, if I'm missing anything in the chat, please let me know. Interrupt me. Is there a way to clear this terminal? Okay, so we have these classes, and let's say we want to list all the students that are enrolled in a certain class. So let's say physics. We want to see all the students that are enrolled in a physics class. Let's try to figure out how to construct that. So select. Yeah, we'll grab all the fields from. So in this, what are the tables that I might need information from for this case? So I want to know who are the students that are taking this physics class.
So students and enrollments.
Students and enrollments. Okay. So there we go. So from students, I'll just left join. So you'll find out what these mean, but pretty much what the joins do is it takes a record. So let's say it takes a student record and it joins every student with the respective classes that they've taken. If we're joining on enrollments, join did select name. Yeah, we can just do first name, last name. From students, join enrollments on students.id equals, and I'll explain what all of this means in a sec. What's the class ID for physics 4? That's a 1. All right. So can someone tell me what they think this is doing exactly? Anyone can take a stab at it.
I think it's saying, show us the first and last name in the students table, where in the enrollments table, the student has a class ID of 4.
Exactly. That's exactly what it's doing. So when you're doing this join, you can think of it as it's creating another table that where each row is a student and the enrollment that they're related to. So let's see what comes out actually first. Come on. There we go. Okay. So Leopold Town. How can we check that? So actually, let's add an ID also so we can see what student ID it is. Oh, so if you notice here in the statement, here I had to say students.id, and here I named it student ID. So in the enrollments table, if you remember, we had the columns student ID, class ID, and we had regular ID. And then in the students table, we had ID and then whatever the rest of them are. So if you're joining two tables, so you have references to both tables. If you have a column name that is the same name in both, you can't have that. So you need to specify pretty much which table you're using. So here we wanted to make sure that the student's ID from the students table is the same as student ID from enrollments. Because it was unique, we didn't have to specify it, but it is better to specify it just so you also kind of see where it's coming from. So enrollments.student ID. So here in the beginning, that's why it didn't let me just select ID. I have to specify the table. Okay, so we want the student ID, first name, last name. Okay, there. Their ID is 4. Select. These are all the enrollments. We can actually see where student ID equals 4. So this will give us, for this one student, for Leopold, all the classes that he took. And one of these classes was the physics one, and that is what we got. This will be a little confusing until you actually start practicing it and pull data from multiple tables together. There are also different types of joins, which I won't go into right now. But yeah, so that is joins. Any questions before?
Yeah. Is the left join? I imagine there's going to be a right join, but does that tell you how you want your table structured, which order the fields are in?
So a left join means that you want everything in your first table. So so when we did the join, there's a table on the left of the join and a table on the right. So left join pretty much means that you want all the records from the students and then only the records that relate to the students from the enrollments. So so if there were enrollments that, also correct me if I'm wrong, if there are enrollments that don't pertain to the students that are in that table, you don't want to include that in there. So your students are your kind of first priority in that row.
All right, thank you.
So on that note, then could you do exactly what you did, but backwards? Instead of left join, you put the enrollments first and then do right join, or is that not?
Let's try it. Why not? I always have to look up the left and right join stuff. So we're gonna find out. So let's do. Join students. Yeah, it worked. Now I wonder if I just put regular join. So if I don't specify left or right, what will happen? So I'll just do the join and we'll see what table is produced. I just want to show you what the join actually does. So we're going to select all the columns. Okay, so here you see it started with the enrollments on the left, and then it kind of appended all the student names that are related to that enrollment. So you can see here, first enrollment is first student, second enrollment is also the first student, and it goes that way. So if we did it the other way,
while you're doing this, is this like reorganizing the tables? Is that why you're not getting like duplicated tables? Is because you're just reorganizing them, not making new ones?
it doesn't create a new table, but it creates something called a view, which pretty much is like a temporary table that is just there for you to use for your select. So select creates like a, actually I think there's a keyword, like there's a specific table called a view, but this is like it's just a temporary table that.
So like the data is still really the same, but it just shows it 2 different ways.
Exactly, and that's the powerful thing about like really relational databases is you can have your data abstracted into these like entities, these objects that are like each table saves its own thing, and then you with just the queries you can create a new table that encompasses all of the information that you need. Can be very specific, can be, yeah. I've also seen joins across like many tables and merging tables, and it's a pretty powerful tool. Yeah, here you just get your student information first, but it pretty much just ends up mixing. Yeah. Okay, well, we're almost done. Should we do one more? One more query before we wrap up? Yep. Okay.
You know what? I think when you do this query, would you mind, instead of like doing an actual query, do like filler data? So what I mean by that is like select star from table name, left join other table name on column value equals.
I understand. So you want like just kind of like a template?
Yeah, like the template for these queries would be helpful.
Yep.
So I looked through the slideshow you guys include, but I didn't see that in there, and that would be really
definitely. So generally you have a few commands. So you have an insert, you have create, you have drop, delete, and update. I think these are the main ones. So insert, start with create. So here you can create a database or you can create a table. So you can create a table and then you put table name. And then you specify your columns in here. So and the columns are in the form of key value. So column name, and column type. They're separated by, what is it called? Commas. So you can also create database and you just put the database name. Drop, you can drop a table and then put table name. Or you can drop a database. Same with delete. So delete, you can delete a table and database. Update is a little more nuanced. I think I might have to look up some stuff, but you can update table. Yeah, the update I'm not gonna, because there's a lot of different ways to do it. You can update tables, you can update records. I don't know if you can update databases. I don't think that's a thing, but yeah, I'm gonna have to look this up. Where's my editor?
I definitely look up the syntax for update every time I use it.
Yeah, it's a little much. Okay. SQL update. I have two screens up, so it's kind of having difficulties. Okay. Also, this website is great for just coding in general. Here we go. So update table name, and then here's what you want to update. So you set whatever value you want, or like whatever column you want. So whatever, yeah. So like this one would, if we're updating, let's say students, we would set like first name equal to this, last name equal to this if we wanted to change the names. And this is where, let's say the first name equaled something specific. But yeah, does that kind of help? Just this, I can actually just copy this in here.
So I was more so talking about the query syntax, but this is super helpful too.
Yeah. Okay, so select, which is the one that I forgot, it's the most important one. So you have select, you have to specify your columns. So you either put your column names, or you can put star. So star just gives you all the columns. That's the only difference. Then you specify from where. So this portion can either be a table name. Actually, it's usually going to be a table name. And then if you wanted to do your joins, you can. So join other table name. This is so I can just put this on a second. And then your condition goes after where. So select something from this table where this condition is met. So maybe where column name equals something, or yeah. So there's different ways to select things. You could also group things, which is something that will probably, I think maybe tomorrow will be touched on, or Wednesday. Yeah. So yeah, the nuances of the clauses will become more understandable. Did that help for this statement? Alicia?
Yes, thank you.
Awesome. Any other questions? Okay, I'll demonstrate one last query, and yeah, we'll stop. I feel like everyone's losing their energy or has lost their energy. Okay, so let's say we want to get the number of students. So we want to select the number of students who are getting an A in the classes that they're enrolled in. So let me grab that prompt just so you can see it. Sorry. Okay. So how would we do this?
I get a question. When you say by the number of students, are you saying like the quantity?
Yes.
Okay.
So let's worry about that, like that specific part at the end. Let's start with getting the students, like a list of the students who are getting an A in the class. So what would that look like? Anyone volunteering?
Maybe like select student dot ID, or you could do all, I guess, depending. You could do the star, that's fine.
Okay.
Select star from students. See, I wish we had like the tables to compare this.
Yeah.
We had like the tables to look at.
So we have some in here. So this is the enrollments.
Okay, so
This
grades
is-
on the enrollment. Okay.
Yeah, this is what the student table looks like.
Okay, so I'm thinking it would be from students left join enrollments on let's see, students.id equals enrollments.student ID, where grade equals, or grade.id, grade equals A.
Grade equals A. Let's see what that does. Yay. It gave us back students. So based on this. We can check actually here because we had all the people here. So there's only 2 people that got A's. It was this person and this person, which is the 2 names that we got. Awesome. Does that kind of make sense to everyone? Or at least it's not too confusing. Michael? Yeah.
Just clarification. So when it says on students.id equals enrollments.id or student ID, it just means like where the tables match those criteria.
Exactly. That's where you're joining. Yeah. I should have added that in my here. But yeah, when you do table join table, you have to specify on what. So on columns. So certain columns. Column equals column. Any other questions? Okay.
And then just throwing a whack at it, I'm gonna say something like find count, putting find count in front of that entire select statement or something like that.
Yes, so we don't put find, but the really nice thing about SQL is it lets you do aggregate functions, which is like sum, count, average, min, max, all those things are supported. So we can just select count star. So this will just return the count of the rows. So how many rows were in there? Actually, I don't want to check all of that again. Let's just go back. Count. Let's see what happens. They return 2.
Is there any resources to get like a better visual representation? Because I just get like kind of confused when like there's so many like, you know, like left join enrollments on students ID equals blah blah blah.
Yeah. I don't know. I think I usually use like an editor or something, like something that highlights which statements are which. But actually, while you're doing this, sorry. So you should take advantage of like indenting and stuff, which is nice that if you hit enter, it only goes to the next line. It doesn't execute. So if I were to do this, we can do select count. Oh, okay, sorry. Select count star. And you can say from,
yeah, I think that'll help a lot. Thank you.
Yeah, definitely. Students. Yeah, it's just on
yeah, I get the concept. You don't have to do it if you don't want.
Yeah.
Thank you.
Anyone else? Okay, just a few things to mention about the benefits of the relational database management system is one of them is scaling. So you're able to have a lot of different users accessing data, so sending queries back and forth and updating and all of that all at the same time. And you're able to even like cluster servers together and have like a database running across them. And so that's a really helpful thing to have a large amount of users using it at the same time. Because if you have an app and everything is, you know, in a certain database, you need to have the ability to give your users like a seamless experience pretty much. Another benefit is the data validation. Like we saw, we specify the data type for each column. So when we're entering data, we lessen the amount of wrong data in our database. So you only get what you're expecting, and that's how it should be. So a well-designed database should have everything. It shouldn't all be just bar charts and just like strings everywhere. You should specify what you want to do. Also data integrity. So there are a few functionalities like what is it called? Transactions and locking, which we'll learn about later, but you're able to pretty much encapsulate your statements in a transaction. And what this does is it pretty much, so let's say in this transaction, you have to do a couple different steps to load your data or do whatever, you're computing something that you want to put into the database. The transaction will only save, it will only actually happen across your, or like to your database if everything is successful. If you get an error in the middle, you're not gonna have like half of your data was inputted and the other half couldn't finish, and then you're gonna have to go back and figure out what you need to delete because only half of it was in there and stuff like that. So those are very, very helpful. And also just like the filtering and searching, like we saw, it's pretty powerful, and you're able to match across different criterias and even have like many tables and have aggregate functions like the sums and averages and count and all that stuff. Anyone in the chat asking questions that I should know about? No, you can't do select count star and star. I don't think so, at least. Let's try it. Yeah, it'll give us an error because you can't do and, or let's do a comma. The semicolon. Yeah, it doesn't allow you. You have to this one. Yeah. Yeah, so the count, you put the star inside because you don't really care about specific columns. You just want to count how many rows. So I'm pretty sure it wouldn't work if you don't put the count or the star inside. Yeah, count star must be, yeah, used to call. What else? So put the column name. Yeah, that works. So this one would come in handy if you have nulls in there. I believe it wouldn't count the nulls, if I'm not mistaken. Is that correct, Raphael? Or...
I'm actually not sure. 99% when I use count, it's count star.
Mm-hmm.
So I'm not exactly sure why or when you would use count with a specific column name or what that achieves for you.
Okay. Last thing I wanted to mention, a few applications that you might see SQL, or like if you're in a job and the way you might interact with SQL is you might have to, like I mentioned earlier, read data through Python from a CSV and manipulate it, and then do your insert statements towards the database. You can do that in Python. You can just have a loop, and you have an insert, and you have your variables, and you're just inserting one after the other. Or you might use a data script or database script. So like those these scripts that we saw earlier here, you'd have to just write scripts that create your tables, that insert data, that do all of that. And yeah, that's sometimes even in an application, like you're writing an application where your user signs up for that app. You're going to want to send in the back end your new credentials towards the database to save them. So that's also something that you'll save. But yeah, I think that is all that I have. Thank you all for sticking through the long lecture on SQL. Yeah, let me stop this recording.